Hi, we're back. I have to apologize. I love history more than physics. And I am wrong about that song. That is not about Atlanta. What was I thinking of? That was about the Battle of Petersburg and Richmond. And I was thinking about it after I said that, and Danville is in Virginia. Danville is southwest of Petersburg, near the North Carolina border. I'm thinking something's not right here, but yeah, I was wrong. My apologies. That was about the Battle of Petersburg and Richmond, and towards the end of the war. You know, the winter of '65. We're hungry, barely alive. Yeah, because Atlanta fell. Now I'm afraid to even say anything, but Atlanta fell in in '64, right? '64. That was Sherman's march to the sea. Was after that. Yeah. So sorry, but you're right. My apologies. It says. All right, we'll get that playing here in a second. But anyway, let's continue, okay? What's WO? That's where we were. Did you guys get that? They were waiting to do that. Yes?
5,000.
5,000 what?
5,000.
The unit labels will get them every time. Joules. Very. What are joules? Where did that come from?
Kilograms times.
Yeah, but what's joules? Where does the word come from? Joules. Jouls. The last name of a scientist who experimented with mechanical energy. His name was Joules. Okay, it was his last name. Joules. Joules. Okay? Joules. Capital J. All right, so it's going to be 5,000 joules. Okay, now what's the work input? Now remember, unless otherwise noted, it's going to be the real, right?
Mm-hmm.
So what is that?
What's
the work input? All right, while they're calculating that, yes?
5,000.
No. That's if it's ideal, John. That's if it's ideal. But if it's not noted, it's always whatever the problem is. While they're thinking about that, let's listen to the song real quick here.
5,000.
No, it's not that. Yeah, see, the Danville train, right? That was the supply line to Petersburg and Richmond. You can break the supply line, you can, win a battle, really.
Winter of '65.
Winter of '65, yeah.
We were hungry, just the valley of life. On May 10th, Richmond fell.
Richmond and fell, fallen.
I remember also.
Yeah, the night they drove Old Dixie down. I don't know what I was thinking, Atlanta. Isn't there one about Atlanta? I know that's Gone with the Wind, but we'll have to look that up. Okay, did we get it yet? Force times, look, this is force. This is what you do, sliding it up, right? So that's force times distance, right? The force is 200. See, Fi times Do, but this is the real Fi. What's the real Fi? Isn't it 200? Isn't it?
Yes.
So 200 times, isn't that 100?
Yes.
Okay, so what's 200 times 100?
20,000.
20,000, okay? 20,000. 20,000, is that right? 20,000. 200 times 100 is 20,000. Okay, you got that?
Yes.
You sure?
Yes.
Okay, 20,000. That should make sense, and I'm gonna point something out in a minute. We're kind of doing this maybe a little bit differently than we have done it, but it's a good way to do it, actually. So what is the WF? Look, it should have taken 5,000, but it took 20,000. So what's the significance of the difference between 20,000 and 5,000?
15,000.
And what is that? What's 15,000? What is that? 15,000.
The WF.
WF, right over here. Right?
Yes.
Isn't that WF?
Yes.
Okay, 15,000. Okay, 15,000. Okay, are you with me?
Yes.
Okay, yeah? Okay, now comes, I think, the most important part of this whole shebang. To analyze the energy, the potential energy change and the kinetic energy change, okay? So do we have that? Do we know what we're doing there?
Don't have it yet.
Don't have it yet, okay. It should fall right off your paper.
5,000.
5,000 is what?
WO.
Yeah, 5,000 WO, but what is it relative to delta PE or delta KE?
Change in potential energy.
Excellent. And is it positive or negative?
Positive.
Very good. He's guessing, which is okay. Ownership. Say it with ownership.
Positive.
Excellent. It's a little guess there, but that's okay. You see, it's 0 here, right?
Yeah.
Isn't it 0?
That's what I was,
Okay.
that's
And it's
what I was-
5,000 here, right? Isn't it always final minus initial? Correct? Right? 5,000 minus 0 is, sorry, duh. Yeah, 5,000 minus 0
It's positive.
is positive, right? Okay. 5,000, so that's plus 5,000 joules. Okay? Now, what's the kinetic energy change?
Negative 20,000.
Excellent. Yeah! Negative 20,000. Now, what's the split? Account for the 20,000. Look. 5,000, it should be negative 5,000, right?
Yeah.
Well, how did it get up here? Well, it had 20,000 joules to get up here, right? But, so it's going to be final 0. It's not going to have any left, right? Because it's all going to be converted to potential energy, right? So it's going to be 0 minus 20,000 is negative 20,000. But wait a second. It should be 5,000. I should have said 5,000. But so what's the split? What's the mechanical energy change? What's the mechanical energy change? The mechanical energy. In other words, what was the energy that I used to get up here? Wasn't it 5,000 joules?
Yes.
So that's the mechanical energy, right? So the mechanical energy is going to be,
Minus 50.
no, well, you don't have to say minus because you're not talking about the change, but it's 5,000 for mechanical. And what about heat? What about heat? What about heat? How much heat was it? How much heat?
150 newtons.
But, no, that's, you gave me a force. How much heat?
Oh. 15,000.
Yeah, isn't it?
Yes.
Oh, right. Voila.
Are we done? Okay. Wait. Have a great day.
The